Hi, my name's Alan Roof. I'm here today to talk about automating your home with a brand new project that's come out of the xLab area of the Office of the CTO at VMware. Don't worry, I'll explain what an xLabs project is in a moment. If you want to contact me with further details about this project, maybe get involved, be a design partner in what we're doing here, then I would love for you to contact me. My Twitter handle is @AlanRenouf, and my email address is renoufe@vmware.com. Looking forward to hearing from you. Let's start the presentation. So let's jump straight into the disclaimer. You're probably best off reading this because some of the features I'm going to be showing you today are definitely in technical preview, and they are part of an xLabs project, and that means we are working somewhat in the future. Talking of xLabs, xLabs is a part of VMware that enables our customers, partners, and employees to innovate. Essentially what we do is work in small teams as part of a xLabs project, and we work to deliver 1 to 3 year ahead of roadmap innovation by basically understanding, what is the next thing that we need to tackle, what is the next thing that we need to work on, and that ends up being something that graduates into one of the existing business units inside of VMware and being taken to market. Some examples of this are a project I worked on before called Project VXR, which has now graduated into the end user computing business unit and has been released as XR Hub. Another example of this is where I worked to understand the requirements to virtualize power substations. That has now exited into another of our business units that is taking it to market and enabling our power industry customers to virtualize their power substations with real-time workloads. So I want to start off by talking about the edge. This will become relevant later on when I talk about how I'm using this technology to automate my home. But right now, let's have a quick discussion around edge. And when I say edge, I really mean those kind of edge locations where they have limited compute. These are the small form factor devices where they don't have a data center. It's often a device that's sat on somebody's desk or on top of a filing cabinet and is very small form factor, your Intel NUC kind of device. It's the kind of area where, and kind of site location, where they have high latency back to the internet or to a corporate network. They have low bandwidth and often have times where that bandwidth goes down, that internet connection goes down, or that network connection goes down. They need all the decisions to be made there locally on site. They need all their applications to be up and running there on site, otherwise they lose money and they lose business from those applications that are needed. This is also the kind of edge where it can scale. I mean, we're talking about one Intel NUC, maybe we're talking about 10 locations with Intel NUCs. Maybe we're talking about hundreds, thousands of locations with those smaller compute form factors where the applications are running there that are key to the business and the decisions that need to be made on those sites. It's also the kind of area where there's going to be nobody sat there waiting to help you if you have IT issues. The IT is going to be centralized inside of the corporate environment or on the end of a phone. They're not always going to be there to hold your hand and talk you through how to fix an issue. They are going to give you remote support and often send you a new unit that you just need to plug in to get everything up and running if you don't already have one of those in the cupboard. These are some of the common constraints that we see for the edge that we are focused on, and this is how we started our project inside of the Office of the CTO, the xLabs project that works on solving some of these issues to provide a platform that enables these edge locations. That project is called Project Keswick, and the goal of Project Keswick is to provide a secure, performance deterministic way to enable 1, 100, 1,000, tens of thousands of edge deployments with simplicity. And simplicity is the key word here. We want this to be super easy to use, super easy to update, deploy, and manage. Let me show you a quick overview of what Project Keswick is.
Enterprises like yours are moving workloads to the edge to reap the benefits of reduced latency and faster operations. But managing workloads at the edge of your network comes with its own set of challenges. Edge locations are often unsecure, with a lack of governance, inconsistent network connectivity, and air-gapped states. It can be difficult to ensure availability and nearly impossible to scale. And there aren't always IT staff present if something goes wrong. Introducing Project Keswick from VMware, a highly optimized integration of Kubernetes with ESXi that delivers a Kubernetes native hypervisor specifically designed for edge deployments. Secure, performant, and deterministic, Project Keswick enables control plane isolation from workers and app isolation for workloads. Through desired state configuration, everything is automated for maximized operational efficiency. You can define how every aspect of the edge location looks, so there are never any outliers. Let your developers concentrate on innovating and leave the infrastructure, security, and scaling to Keswick, your easy button for edge. Join VMware Project Keswick as a design partner today by emailing keswick@vmware.com.
So hopefully that gives you the high-level overview, but really what we're trying to do here is make something that's super easy, something that deploys in minutes and not hours, and that means it's fully automated. It's the idea of being able to take that USB key, put it in some supported device, some small compute unit, and then boot that entire stack up so that it's up and running on that equipment with no intervention from the end user. So the kind of thing that a manager could do in a store, put a USB key into a device, power it on, and let the rest happen automatically. We are obviously focused on security as part of that because these devices are not always in a secure location. It's very easy to pick one up and walk away with it. We're also concentrating on the security from the workload point of view as well, ensuring that we have control plane isolation from those workers that will be running in there, so that if somebody does break into that store's applications, they're not easily able to get into the other applications or bring the entire device down. We've spoken about scale already. Obviously, we are using automation at its most here with principles such as GitOps. The ability to be able to have a single source of truth in a Git repository and be able to version that and use that as the area where developers will commit their changes to. It will then run through some tests and automatically roll out through an approval process and by passing those tests to the edge sites in a controlled way. We are relying on the years of virtualization and innovation that's happened in ESX to make the most of that hardware. We're using the features that have been built into ESX and adding Kubernetes on top of that and then automating the entire thing. So how does this fit into home automation? Well, I was looking for a way to automate my home, and at the moment home automation is very fragmented. There's applications for every single part of that, whether it's controlling the light bulbs or the locks on your doors or the sprinkler systems or the garage door. All of these require separate applications at the moment. And as I started to look into how I could automate my home, I'm currently building a new home and I wanted it to be a smart home. I started to understand that these things were fragmented and look into ways that I could automate my entire home environment. What's more than that is that I wanted to use this as an opportunity to learn. So I came up with the concept of home ops. And what that is an operational framework that allows IT enthusiasts to use DevOps best practices used for application development such as version control, collaboration, compliance, CI/CD tooling, and then couples these with an appetite to learn and apply these to home applications. So what I'm doing is essentially taking the same principles that I would use in a production environment to manage a production workload and using these in my home. It's a way to define my entire home as desired state configuration files for the infrastructure, for the home applications, push these to a Git repository, and then have automated testing done on those and deployment down to my devices that are going to be running my home applications. The approval process is obviously a little bit different at my home. It's not my manager, or well, I guess it is my manager. It's my wife and my children who are going to be using these things, so therefore they need them to be up and running much like a production environment, and they need me to make changes without causing them issues. The idea is that you never touch the production environment. The production environment in my case is the one that's going to be controlling all of these things. It means that I can do things like test things on my laptop, try out the latest integrations. I can deploy them on my laptop and make sure everything works before I push them into the production home environment. If they don't work, I can easily roll back and revert them, because it's as simple as reverting the Git repository and then that single source of truth being pushed down to my device that runs my applications and controls my home. I can see the complete history, I can see where I messed up, and I can easily, not make those same mistakes again. These principles come in handy in a production environment when you're auditing. The overall objective is to nerd out in my home lab and for ultimately me to learn new concepts and new applications and new methodologies that I could apply to my production environment at work by testing these out at home. It's about learning the new software products in your spare time and using these for something useful at home, so that when you go into work you can, again, learn from these mistakes that you make at home and use them in production environments. So the first thing I did was went out to solve the issue that I had with home automation being fragmented. And in doing so, I found an application called Home Assistant. Home Assistant is an awesome application that you can deploy onto a device and is used to hook into all of your appliances and your home automation options that you have at home. It's that single pane of glass that you can use to manage all of your devices. It's a free application. There's a container version available, which makes it super easy for us to deploy onto our Keswick node. And it has a super wide ecosystem of plugins, and you're able to download these plugins, configure them, and have all your devices working in the same place. There is an absolutely huge community for this, and it includes some really powerful automations as well, where you can define a way to interact with these devices that you've added. For example, I can hook into my home router with a plugin, and I can also hook into my security cameras with a different plugin. I can then create an automation that would say if if all of my devices for my mobile phones are not hooked into my home router, then enable my camera, because I clearly know that my entire family is away from home and therefore I want my camera to be monitoring what's going on. That's just a simple example of some of the automation that you can do with devices that were not designed to work together, but using something like Home Assistant can indeed do that. So let me describe to you first of all what my infrastructure looks like with Project Keswick and how this works for me. So I have my USB key, which I've inserted into my Intel NUC and powered that Intel NUC on. That has completely built out my system without me even touching it. It's built out the ESXi privilege layer, where we've bootstrapped the environment and booted into ESX. As part of that, we have our Keswick service installed on this, and we use TKG as the Kubernetes infrastructure for this entire node. We then have our worker nodes ready, sat there for us to be able to deploy our applications. As part of that, we have something called Flux CD, which is used as the continuous deployment and integration with our Git repository. It looks for a Git repository, which we define in our ks.cfg as part of the automation. I'll show you that in a moment. It pulls those workload definitions down from my Git repository and then pushes those applications that I'm going to use on my home network, and it pushes them and enables them. You can see I've got metal-LB on here, which essentially makes that Home Assistant container available to my home network and gives me an IP that I can connect to access that. In my case, I have a NFS server running on my Raspberry Pi as well, so that I can store the persistent information that I need in a volume that's attached to my Home Assistant. And this really does hook into those network devices that I have available at my home and allows me to automate those devices. And ultimately gives me a control panel that I can use on a tablet that I have and I will set up in my home once it's built, that my entire family can go up to and push a button to, turn on lights or to enable the security cameras or start my hot tub so that it's warming up and they're able to get into it. That kind of automation, and it makes it super easy. So let's take a look at a demonstration of how this works. So for us to get started, we'll need a USB key or a SD card, and we'll also need the Intel NUC obviously, and we'll need the ISO that has the ESXi/KESIC build on it. As part of the build, I will write the ISO to the micro SD card, and then once that is done, I will drop the ks.cfg that you see in front of you onto this. This is a normal kind of ks.cfg which we'll provide as a sample, but it includes some information that enables it to hook into our Git repository. You can see here where I've defined the github.com repository that I'm going to hook into, and obviously I will give it my token that enables me to hook into that and pull the information through our CI/CD pipeline and through Flux. So I'll drop that ks.cfg on that micro SD card, insert it into the device, and then power it on. Once I've done that, you will see what looks like a normal ESX build, but what it'll actually be doing is configuring that device with ESX, standing it up, getting to the point where it literally pulls down the GitHub definition files to deploy the applications onto that device. So once the device is set up, it will go and pull those, and let's take a look at what these might look like. Here's a copy of the files that I have in my Git repo at the moment, so let's take a quick look through these. There's the Flux system. These are the ones that are just used with Flux to understand how it syncs with the GitHub repository. And then as I go through these, you'll start to notice how it deploys my applications. So I have a YAML file here that defines what my Home Assistant looks like. We can see it sets up a namespace, and then it does the deployment of the Home Assistant application from the repository, pulls down the image, and then essentially makes it available. It uses that NFS point I pointed out before on my Raspberry Pi, and then stores the information through a volume on /config that stores the information for my Home Assistant application to use, so that when I reboot that Home Assistant, or if it goes down and comes back up again, I've got the persistent information stored for my Home Assistant configuration. It also creates a load balancer port so that I can access my application on my home network, and later on I'll show you how I can access that externally from my network as well if I'm out and about on my mobile phone. So that's fairly easy to understand. We're deploying a namespace, the application, and then we're standing up a service that adds that port to the load balancer and gives me an IP address that I can access this on. The metal-LB is a pretty standard configuration. You literally pull this from the internet and paste it into the configuration file. This will go through and set up the metal-LB service. The only area that I adjusted here is I gave it some ports on my home network to use, so that it can pick up these and use these as clustered IPs and allow me to access the applications that I deploy on my home network. In this case, it's using my address range from 4240 to 4250, which gives it a range of 10 IPs that it can use on my network. I've got my NFS persistent volume that I mentioned earlier. This essentially tells it how to hook into my NFS share on my Raspberry Pi. This could quite easily be a Synology device or a QNAP device, where essentially it's using this to store the configuration from my application. And then lastly, I've got a DuckDNS. DuckDNS is a service that enables me to have a free DNS name that I can essentially register my current IP address on my router to enable me to hook into my information once I have it. You can see I've got alanrenouf.duckdns.org, which will essentially, once this container boots up, it'll reach out to DuckDNS and it'll register my current IP address, my current external IP address, with that DuckDNS service, and therefore allows me to access alanrenouf.home.dns.org and pushes that all the way through to my container that I've stood up. So you can see how this is all hooking together, and what my NUC, once it's booted ESX, it's built the Keswick environment, it's built the Kubernetes environment, and then it will pull down this information and stand up my applications. So essentially what I end up with is Home Assistant application running in Kubernetes on my Intel NUC, and all stood up with all the plugins that I've downloaded and configured from that NFS share, and has everything up and running. You can see I've got it hooked into my home router to tell me who's here and who's not. I'm currently the only one home. My wife and my kids are not here at the moment. You can see it's hooked into my Tesla. There's a plugin for the Tesla that easily brings my stats into there so I can take a look at it. It's pulling the air temperature from my pool system so I know how hot it is out there at the moment. I can actually control more of my pool. I can see a temperature gauge of my home, and I can see how warm my pool water is for the entire week, or go back even further. I can see a list of the information that's gone on with my pool. I can easily turn my pool lights on and off using these simple buttons. And again, this is displayed on a tablet in my lounge where my kids and my wife can go in and hit a button to be able to turn these on and off. Go and turn the spa on, turn the pool on, turn the waterfall on, and see the information about that. It also has a map feature where I can easily see where my devices are, where my Tesla is, where I am, where my kids are, where my wife are. It has a calendar feature where I can see what's going on in my calendar, and it has a shopping list feature that we can use as well. These are all plugins that I've enabled, and it really is down to your home network and what you want to automate and how you want to automate it. I won't go into the details of Home Assistant. It's super powerful and super awesome to use to integrate your home. You can see how I've stood this up and it's running. So let's take a look at an example of adding another application to our environment. And as we're using GitOps, we will not hook into that environment at all. What we'll do is we'll simply update Git. So let's go into our code repository. Let's start a new file, and in this case we will use it to deploy Portainer. So let's start a new file called Portainer, and then we will grab the information from the internet that enables us to do a standard Portainer deployment. So let's paste that information on how to install Portainer, or how to deploy the Portainer container. And let's take a quick look at what this looks like. You can see we're simply setting up a namespace, a service account, the cluster role binding, and then the service where we can again use our load balancer that we set up with MetalLB to expose a couple of ports so that we can actually access Portainer. And then it's going to do the deployment of the Portainer application. And that will allow us to access the Portainer on our Intel NUC so that we can use that to take a look at our container environment on our Intel NUC and use that as a UI to really manage what we're doing with Kubernetes on our Intel NUC and our Keswick deployment. Before we do that, let's take a look at what was actually deployed through our current configuration. You can see, as I said, all of this was pulled down from Git, and we have all of our containers up and running. You can see where it's deployed our Home Assistant container. You can see where it's deployed some Flux system containers, and you can see where it's set up MetalLB. We can also take a look at the services, and we can see where it's taken the network port, the 4.2240, and made that available to the Home Assistant application. So let's deploy our new Portainer application, and we'll see that kick in and be deployed automatically on this node without us even touching it, simply by going in and creating a new commit. We'll sync the changes, and then we'll go back to our screen, and we will do a get pods or namespaces, and we will monitor that, and we'll see how long it takes. Oh, it's already started. You can see this is really quickly synced with our Git repository, pulled down the latest definitions of what needs to be on there, and it's automatically starting to stand up our Portainer environment. In fact, you can see that it's already up and running. So let's take a look at which IP it chose. You can see that we have a new IP 241 that is now on our Portainer container, and that will be on port 9000. So let's take a look at that. So we've got a new container now with Portainer installed. So let's go through the quick configuration of that container. We'll go in and we'll see what this has picked up. You can see it's already found our local Kubernetes deployment. And as I click on there, we can see the information about our Kubernetes deployment, and we can start to take a look at what's on there. We can see all the namespaces that we've set up already, that we spoke about before. We can see the volumes that have been set up and how we might use these. And as we go in, we can see the applications that have been deployed. So just a recap here, you can see how we added a new Git file to our Git repository, and the xEC node automatically synced with that repository, pulled down that application and deployed it to my home network and enabled that for access to us. And that could be, any application definition that's available, whether that's an application that's been developed by you or somebody that you have downloaded it from on the internet. In conclusion, you can see how we can use this awesome new xLabs project xEC, to manage our home network purely through Git. We can run tests on there to check that everything's okay. In fact, in Git, I have a test that runs to check that my Kubernetes definition files are correct. And then if that passes, it deploys it to my production environment. This obviously was used to manage my home network, but you can see how this could be used to manage 100, 1,000 edge deployments. And if that's something that you're interested in, please do feel free to scan this QR code right now, or reach out to us at xEC@vmware.com, or contact me, Alan Renouf, on Twitter, or renoufe@vmware.com. Thanks for your time.